Good morning, friends. Welcome to Rammer Math TV. My topic today is correlation and regression. These two measures are very much related to each other, and you can see here the difference between the two. The correlation determines a linear relationship, whether it is strong or weak, while regression describes the nature of the relationship, and this is represented by a linear equation. So by using this linear equation, you can predict the value of y given the value of x. So this is the definition of correlation. This is the formula of the correlation. Do not worry about this one. Don't worry. This is already incorporated in the Microsoft Excel. These are the assumptions. These assumptions must be uh, complied before the application of the correlation coefficient computation. So this is my sample problem. The column for cars represents the x variables, while the column for revenue represents the y variables. So if you construct the scatter plot for this data, you can see that the points form a line approximately. So these are the research questions. So we need to find the strength of the relationship and the significant relationship, whether it exists or not. Okay, so these are the scale of this is the scale of correlation coefficient and the corresponding value. So what do you think will the value of r belong? To what bracket will the value of r belong? So let us compute. So let's go back to the data. Let me show you how to compute the correlation using the Excel. Okay, assuming that we start from the scratch. So to compute, okay, assuming that the data are already encoded in the Microsoft Excel. So to compute the correlation, if you have started with the home, you left click the formulas. Then you left click the more functions, move the cursor to statistical, and then to the correlation. Left click. Okay. So for array 1, you left click the first number of column A, left click and hold towards the last number. Then left click array 2. So for array 2, you left click the first number of column B, left click and hold towards the last number. And then left click OK. So that's how to get the correlation coefficient. So with this value, we can say that it belongs to the last bracket, that is the very high correlation. 0.98 belongs to the very high correlation bracket. So this is the result and conclusion. So there is a very strong relationship between the number of cars a rental agency has and its annual revenue. Okay, let's use the t-test. So according to the result, by the use of t-test, the null hypothesis is rejected. So how is this done? Okay, so given the value of r that is 0.982, let's have the website. You can click here. I can encode here t-test calculator for correlation. Can you left click the quick p-value from Pearson R? Double left click. So our R score is 0.982 and the number of data values are 6. And let us use the 0.05 level of significance and then calculate. And this is the result. If you compare the p-value of 0.00483 to 0.05, this value is less than 0.05. That means you have to reject the null hypothesis. And that also means that there is a significant strong relationship. That's why, in the conclusion, we can say that by the use of t-test, since the null hypothesis is rejected, there is a significant relationship between the number of cars a rental agency owns and its annual income. Okay, so let us compute the regression. Since we have a very strong relationship, that qualifies us to find the regression. This is the formula. Okay, so these are the research questions. And by the way, friends, if some of you are new to my channel, please don't forget to subscribe and hit the notification bell to get updated with my latest uploaded videos. Thank you. Alright, this is the solution. Okay, so to compute the regression for this, okay, let's have another website for this. Let's go back. You can have the correlation calculator, a regression calculator, I mean. Okay, so you left click this one, quick linear regression calculator, double left click. Okay, so using the encoded data values, you left click and hold, left right click, copy, left click, right click, paste. For y values, left click and hold, right click, copy, left click, right click, paste, and then calculate the regression equation. Left click, and this is the result. This is the linear regression derived from the given data. That's why we have this equation. Okay, let's compare. Okay, they are the same. Okay, so given this linear equation, you can predict. For example, if x equals to 15, you simply substitute x by 15, then do the arithmetic, then you have y equals to 1.986. So if you have x equals to 15, then y equals to 1.986 by using the regression. If x equals to 40, then the result of your y is 4.636. Okay, let's have the multiple regression. Okay, this is used when you have two or more uh, x variables and one output variable y. So these are the assumptions. This must be complied before applying the multiple regression computation. So these are the formulas. Okay, don't worry about this one. These formulas are already incorporated in the websites. Because this is our sample problem. Okay, so how to compute the regression equation like this? So you can have the website. Okay, we can encode multiple regression calculator. Okay, enter. Okay, you can click this one, double left click,